I think the camera needs adjustment.
You there? Oh, I get it.
It's too hard for me.
Okay. Good afternoon, young scientists. Today we are coming to you from a high-tech of Maine. My name is Dr. G and I'm a scientist. And staying safe at home with me are
Lightning Liam.
and
Okay, this time you don't have to say my name. Electric Eli.
very good, Electric Eli. So we hope that you're all joining us right now, and we are going to talk today about the Lunar Olympics. But before we start talking about the Lunar Olympics, I want you to gather the supplies that we need for today. So we will need a bathroom scale. Okay. We will need some type of masking tape. Any type of tape would work. We will need Q-tips and measuring tape. Okay? And if you have a calculator, or maybe the adult that is at home with you can help you calculate what we are going to figure out. Okay, so let's just repeat it. Masking tape, any type of tape would work really. Bathroom scale, measuring tape, and Q-tips. Ready? Okay. So it's a good day to talk about the Lunar Olympics because this year we were planning to have the Summer Olympics in 2020, but because of the pandemic, it was postponed. It will take place next year, summer 2021. The other reason that it's always good to think about the Lunar Olympics is that today another American astronaut took off towards the International Space Station. So actually an hour and a half ago, around 12:30, I believe they took off, and they're going to join the rest of the crew in the International Space Station. And this astronaut is joining another 3 astronauts who are currently on the International Space Station. So always great to celebrate our great scientists out there. So what would be special about holding the Olympics on the moon? Do you think it would be any different than holding the Olympics in Japan or in May?
Yes.
Yeah? You think it would be different? How would it be different?
There would be no gravity.
Okay, so is there no gravity on the moon, or yes, Liam?
There would be less gravity than on Earth.
Very good. So it's less gravity than on Earth, right? It's not no gravity. Sometimes we think that there is no gravity on the moon. It's not accurate. There is gravity, but there is much less gravity. Do you have an idea why there is less gravity on the moon than on Earth? We talked about it yesterday. If you joined us yesterday, this discussion about craters and how they're created. Do you remember what we said about what makes craters? What makes meteors to all those rocks to rotate around Earth? Do you remember?
Gravitational force.
Very good, gravitational force. So does Earth have more or less gravitational force and why? Why Earth has more gravitational force than the moon?
Well, this is a random guess.
Okay, go ahead. Very good. It's true. It's a good random guess. Always make observations, right? You're thinking about, well, if it's different, there's probably something there that has to do, maybe something there that has to do with that. So as Liam said, yes, that's correct. The Earth is much larger body than the moon, and therefore it exerts, right, much larger gravitational force than the moon does. Very good. Yes, Eli?
It's like the Earth is like a parent to the little baby.
Okay, and Liam, Eli brought the analogy of a parent and the baby. That's a cute analogy. So if it helps you remember it, that's a good analogy to remember. So let's go ahead and try to figure out how much we would weigh if we were on the moon. So when we say weight, we actually calculate in the gravitational force. When we want to just refer to how much our mass is, we should use that term. So it's actually mass. But we are going to calculate the weight. So go ahead, Eli, and stand on the balance, on the bathroom balance. And Eli weighs on Earth about 48 pounds. So to calculate how much he would weigh on the moon, we need to multiply it by 0.16. You may ask, why 0.16? That's a good question. Do you have a guess? Huh?
Because that's how much less the gravitational force is on the moon.
So it's only 16% of what the gravitational force is on Earth. Very good. So we are going to calculate 48 multiplied by 0.16. Your weight on the moon will be only, are you ready? 7.7 pounds. You will be like a really, really little baby. Liam, are you ready to test yours?
Not really.
I want to go to the moon.
So Liam weighs 92 pounds on Earth. So go ahead, friends. And if you use a calculator, you're writing whatever you weighed on. You want to do it? Go ahead. And now you multiply it by multiply. Very good. By 0.16. Again, it's just like saying 16%.
14 pounds.
14.72. Wow, you would be weighing as you weighed when you were, 2 years old? Probably. Very small. Did you calculate your weight on the moon? If you can share with us.
Text us.
Yeah, send us a message. Let us know how much you would weigh on the moon. So that's pretty cool. So yeah, we are talking about how the gravitational force is affecting, right, our weight. Mass doesn't change. Our mass doesn't change, but our weight is affected by the gravitational force. So now let's imagine that we will start our Lunar Olympics, our Olympics on the moon, with long jump. What is long jump? Do you know? Yeah, go ahead.
Long jump is a game where people run and then go like, and then jump.
Okay, very good.
And they see how far they can jump, and it's like a competition.
Yeah, Eli, go ahead.
Sorry.
What is long jump? Do you want to add?
Well,
No.
okay.
So you may know that the Olympian who is holding the record is Mike Powell, and you can see how impressive his jump is. Mine won't be so impressive even if it was on the moon. That's pretty cool.
He'd probably go like twice the.
Yeah, and Mike Powell jumped 29.4 feet on Earth, right? So to calculate how much it would be on the moon, we're going to multiply by 6. So really fast. Go ahead. You want to do the calculator work? 29.4. Friends out there, go ahead and calculate with us. 29.4.
Wait. So
29.4
29.4.
multiplied by 6.
6 what?
That's multiplied by 6. Very good. That's the relationship. Very good. And now equal to 176.4 feet. That's a very, very, very long jump. So let's go ahead and try that at home. We are not going to run. We're just going to jump from standing, from resting. So go ahead. Maybe you can start.
Yeah, go ahead.
So that will be your starting point, just where the tape starts.
And if you jump higher, I'll move the tape.
Okay, and whenever you're ready.
I'm running.
No, you don't run. You just jump.
Okay. Like this.
As furthest, Liam. As furthest as you can.
Wait.
Like
right now?
From that. Yeah, right now. Okay. Can you do it without moving? Try to do it. The rule is without moving, okay? Okay, perfect. Stay where you stand so we can measure. And we are going to measure how far you jumped. So you jumped 40 inches, okay? So Eli jumped 40 inches. Very good. So if you jumped 40 inches, let's multiply 40 by 6. I know some of my friends are really good in math out there. Can you multiply 40 by 6 without a calculator?
40 by 6. Wait, 40 times 6?
Uh-huh.
Times 6.
Do just 4 multiplied by 6. That's the camera effect. So.
Wait, I know.
Yeah.
24.
Very good. But
240.
very good. So 240 inches. Good job, Eli. You would jump really far. Liam, you want to try? So you just stand at the beginning of the tape, and you're jumping from rest, right? You're not running.
Not like that.
Okay, go ahead. Okay,
Wow.
stay where you are. Oh, can you do it again? And stay where you are.
He had to.
So we can measure you. We can make it longer. Okay. Perfect. Stay.
Right there.
Stay where you are. It will be close enough. Eli, you want to help me? Want to keep stretching it? Very good. And you may need some teamwork here, so it's great. 67 inches, approximately. So 67 multiplied by 6. 60. Maybe that needs a real calculator, right? Or at least a piece of paper. So 67 multiplied by 6.
402.
Very good. 402. Perfect. How much did you measure out there? Let us know.
Wow.
Are you further away than Liam and Eli with your lunar jump? Let us know. We're curious to hear. So, what do you think would happen if we would have the space here to run before the jump?
I go like twice.
You could go further, right? Why do you think you could go further? Talk about the energy.
Well,
What would
when
happen?
you pick up speed.
Right.
So you pick up speed. So and then you go like.
So when you pick up speed, you have more what?
More energy.
You have more energy. Do you remember what the name of the energy that we talk about when it's moving? What's the name of energy that is moving?
Anybody? Energy.
Kinetic energy, right? So by running, you gain more energy, right? You specifically have more kinetic energy, so then you can jump further. So try it again, maybe outside when it's nice outside. It's raining in southern Maine, but in a couple of days we'll have nice days that we can run outside again. So go ahead and try it outside with a run, and let us know how it affected your lunar jump. So the last thing that we want to experience with our Lunar Olympics today is javelin throw.
Yeah.
So what do you think will happen if we would try to throw a javelin on the moon?
Well, I think it would float. It would only float, then at some point it would start lowering.
Okay.
But that would take a long time.
Okay, very good. Very good. So Liam said it will almost float, right?
Yeah.
Why?
Because the gravity isn't pulling it down.
Isn't pulling it as hard, right? The other reason, do you know another reason, Eli? Another reason? Friends, do you know another reason? So gravity, the fact that there is much less gravity, there is definitely the first reason. What else is happening on the moon?
There's not a lot of air.
Oh, very good. So there is not a lot of air, right, on the moon. Have you ever seen astronauts walking on the moon? Did you see that they have oxygen masks? Why? Because?
Well, because there's not that much air, but like if there was like air like on the world and there was like still less gravity, but there's more air,
Yeah.
you wouldn't have to wear. Well,
They wouldn't have to wear
those
masks.
all those suits.
Yeah.
Well, yeah, but if so.
Okay, so I'll take it from here. So here we need to think about two things. First, gravity. Second, the fact that there is less
Air.
less air, and therefore there is less what?
Friction.
Friction, right? And the energy is conserved, right? Because it doesn't interact with the air molecules. And therefore, you would be throwing your javelin much, much further. You want to know the exact number?
Yeah.
I calculated it ahead of time, and it will be 19,000 times further. I bet I would be holding the world record then. Do you think?
No, I would.
Okay, so let's try. Our javelin will be a Q-tip. Okay? So who wants to start? You want to start? Okay. Okay.
So
That's your start line. Yes, starting
a
line.
jump and throw?
No jump, throw.
Okay.
Okay. Okay. So let's measure where our modified javelin landed. Can you hold it? Can you hold it?
Yes.
Thank you. It's important to work in a team. Our javelin landed 81 inches, right?
Let's go here.
So let's calculate 81 multiplied by 19 thousandths. 19 thousandths.
So 81 multiplied by 19,000.
Yeah, how much is it? Too big of a number. 1,539,000. That's pretty high. How much did you get there? Higher? Lower? Okay, we'd like to hear about that. Liam, your turn.
I'll take my two. What if it lands on the table?
We'll figure it out. Don't step over. Whoa. Okay, too far. Away from our camera. So we can guess. We can guess. We're going to get some help here in measuring it.
Other way.
Oh.
Other way. You'll get that.
Okay.
Oh my gosh, oh my gosh.
I have an invisible helper. So it's about 176 inches.
That's about like.
It's about 176 inches.
No,
Good
it's
job.
about
Liam.
it's 100 more than you.
And again, we multiply by 19,000, and that will be 3,344,000 inches. Feel like you made your record today, did you?
But you didn't win the contest. Yeah.
Okay, friends. Well, I hope you enjoyed joining us today, talking about how it would be if we would hold our next Olympic Games on the moon. Remember to follow Chris Cassidy, our American astronaut from Maine, who just launching now or launching to the on his way to the International Space Station. The links are on our Facebook page. And let us know if you have any questions. We would love to answer any questions you have. Be safe. Bye.
Bye. The magical person is helping us get rid of us.